you have not watched the video prior to this one, I'm gonna link it. It's down in the description below. Um, this is the this it was the introduction to this lesson. Okay. All right. So let's take the first problem in here. We will convert this radical expression into exponential. So this would look like x to the power of 4. The index is 3. Y to the power of 5. The index is 3. Okay. Now, whenever your exponents are greater than 1, we want to separate the whole number exponent because that will come out of the radical sign. I'm going to write that solution in here. Just disregard this one for now because I did not think this through, I might need more space. Okay, so you have x to the power of 4 thirds, y to the power of 5 thirds. Okay, now equals x. I'm going to separate the 3 over 3 on the 4 thirds. So that's 3 over 3 plus 1 over 3. That becomes 4 thirds. Y, same thing, 3 over 3 plus 2 thirds. Okay, so I'm just really breaking down the exponent into whole number um, and the fraction. So remember, 3 over 3, this is just like equal to 1, right? And 3 over 3 is also equal to 1. So that would mean this is a whole exponent, that's a whole exponent. Whole number exponent is what I mean. Okay, so we can rewrite this as x to the power of 1 times x to the power of 1 third. Because 1 third is less than 1, then this exponent that is less than 1, we can rewrite it back into a radical. Same thing with your y times y to the power of 1 and then y to the power of 2 thirds. Okay. Now, every single one, these are all multiplication, right? Every single one that has a whole exponent that will come out of the radical sign. So that would become x for this part right here, y for this part right here. And then these two, they both have 3 as denominators. So remember, we can rewrite it back into a radical. This would become x to the power of 1. That's the numerator there. And then this is y to the power of 2. And since they both have the same denominator, then they could share the same radical sign and the same index. So this is the complete answer, simplified answer for this problem. Okay, so x y to the power xy and then cube root of xy squared. Okay, now this is just one way to answer it. I'm going through the method of converting them into exponential. There are, of course, many different ways of solving this. Again, this is just one way to do that. Okay, so let's solve the second number. Okay, so you have two radical, and so what we need to do is to convert them. I'm gonna rewrite them here again, so I have more space. Fifth root of x to the fourth times square root of x to the cube. Now remember, if it's a square root, that means your index here is 2. So now that you have radicals, you can convert them to exponential. So x to the fourth, you just copy the base, the radicand, which is the one inside the radical sign, you divide it by the by the index. All right, so that's the fifth group. Now remember, this one right here is not the same as 5x to the fourth. Okay, so this 5 is a coefficient. This 5 right here is actually an index. Okay, I know I wrote it a little bit too big. Okay, so now the other one is x to the power of cube, which is that, and then over 2. Since you're multiplying and their bases are the same, again, that's the important part. The bases need to be the same for them to be able to be combined. Okay. So now, since you're multiplying, they have the same basis, then you can write it as x to the power of 4 fifths plus 3 halves. Okay. So now you can just combine the exponents. So I'm going to do that here on the side, plus 3 over 2. Their common denominator is 10. Okay, so now this could be multiplied by 2 and 2 to make it 10, multiplied by 5 and 5 to be 10. So that becomes 8 plus 15, which is equal to 23 over 10. So all of these becomes x to the power of 23 over 10. Okay, now, however, if you notice, 23 over 10 is greater than 1, right? So therefore, we have to break down the whole number and the fraction, the part of it, the part of a whole. So this becomes x to the 20 over 10 because 20 is the biggest number that can be divided by 10 plus 3 over 10. And so we can rewrite this as x to the power of 2, 20 over 2, times x to the power of 3 over 10. We just separated the exponents. We gave them both bases of x. Since this is a plus, then that means they are being multiplied. If this was a minus, then you have to divide them. Okay, so this whole number exponent, that becomes x squared, and then this fractional one becomes a radical. So you do x to the power of 3 because that's the numerator, the index is 10. So this is the final answer. X to the, so okay, so let me rewrite that here. Okay, so all of the solution, the final answer here is x squared and then 10th root of x cubed. Okay, so that's the most simplified radical version. Now, I need to make sure to also explain that while this is the radical version simplified answer, this also is a simplified answer, okay? Only in exponential form. Exponential form, radical form, both of them are correct. It only depends on whatever is being required of you to provide. All right, let's do the next one. Now you have many radicals in the inside the parentheses that are being multiplied, and then again you're raising it to another exponent. So my for again, there are so many ways to solve this. The way I'm gonna solve this is that every radical I'm gonna convert into a exponential. Okay, so that becomes x to the 4 thirds because x to the fourth first, and then divided by the index times x cubed for this one right here divided by 5 times x cubed again divided by 2. And then all of these can be raised to the power of 1/3. Now, you can simplify the ones inside first and then raise it to the power of 1/3, or you can all raise it to 1/3 and then later on simplify. It doesn't really matter, okay? For me, what I'm gonna do is I'm gonna multiply the one inside the radical first. So this would mean x to the power of 4/3. Since I'm multiplying, then I need to add every single one of them plus 3/2. And then all of these to the power of 1/3. Now I'm gonna have to add all the fractions plus 3 over 5 plus 3 over 2. So my greatest common denominator is going to be 30, 15. Yeah, it's going to be 30. So 30 and 30. So now I need to multiply this by 10 over 10, this one by 6 over 6, this one by 15 over 15. Okay, so the first one is going to be 40, the next one is 18, and the next one is 45. And when I add that, that's our big number. 95, 105, 113 over 30. Is that right? 80, 95, no, 103. Okay, so that's going to be equal to 103 over 30. Is that right? 80, 95 plus, okay, 103 over 30. So the one inside is just x to the power of 103 over 30 raised to the power of 1/3. Now remember, when you're raising to a power, that means you need to multiply the exponents, okay? When you're raising to a certain power. So this would become x to the power of, when you basically we're multiplying 103 over 30 times 1/3. Okay, well, that becomes 103 over 90, right? So x to the power of 103 over 90. But this fraction in itself can be simplified. You can both divide them by 3. Oh, no, I can't really. So this is it. I can't really divide them by 3. So that's the simplified version. Okay, now what? But remember, 103 over 90 is greater than 1, right? So that could be rewritten as x to the power of 90 over 90 equal up, and then 90 over 90, and then 100, no, 13 over 90. Okay, so again, that could be rewritten as x to the power of 1 for this part right here, times for the part of 90 over 90, times x to the power of 13 over 90. Okay, so the whole number exponent will stay out, and then this one becomes x to the power of 13, and then 90 index. So your final answer is x times 90th root of x to the power of 13. Okay, so this is one answer right here, but this is also an acceptable answer, again, depending on what your teacher wants. Okay, so the third part of this will be solving the other three types of problem. I'll see you there.